Hello everyone. For this year's Collaborative Science Project, our project is inspired by a very real and relevant issue, which is classroom heat. Our project is investigating how different types of lighting affect indoor temperature and how this is linked to our overall learning at school and in our classrooms. Briefly, our experiments included us using two different types of lighting, which is incandescent lighting and on the other hand LED lighting, and we used two classrooms which have different types of lighting, and throughout the school day we measured the temperatures that these different types of lighting give out to the class, and based on that we're investigating which is the better option as a lighting choice to use.
So now, to test our hypothesis, we set up two identical indoor environments, each having different lightings, one as LED and the other as incandescent traditional lighting, and we made sure that all other conditions are controlled in order to make sure that any type of temperature change is only due to the type of lighting used and no other external factors. We set up a digital thermometer in the middle of the room and away from any light exposure, and we measured the room temperature throughout the whole day, every hour, giving us a full day cycle of data.
Now let's talk about our physical model. Here we have two classrooms indicating the classroom that we used that had the incandescent lighting and then the classroom that had the LED lighting. Here we have the thermometer that checks the temperature of both the classrooms, in which above 36 temperature at 36 Celsius indicates that it is harmful for the conditions of the students, and when it is below 36 degrees, it indicates that it is a safe environment for the students. Now moving on to our data collection, we see that our data actually proves our hypothesis to be correct, which is that traditional lightings in classrooms are actually emitting more heat and disrupting students' behavior and environments. Here we see that the change in the temperature for the LED lighting is so much less than the change in the temperature for the traditional lighting, which means that in incandescent lighting classrooms, it heats faster than the LED classrooms.
Now, our project is related to two very sustainable development goals, which are 11 and 12, sustainable cities and communities, and responsible consumption and production. Both of these goals relate to how we can make our surroundings, our environments more sustainable with how we choose to consume energy, produce energy, which is related to light in this case. Now, when we come to our overall conclusion and real-world impact, this experiment has a very important real-world impact because firstly, it highlights the importance of a very comfortable learning environment because cooler classrooms are known to enhance student concentration and their well-being. Secondly, it promotes energy efficiency because through our experiment and data collection, we are able to analyze that LED is the better option. However, we are taking into consideration realistically that LEDs are more expensive as a startup option for schools especially. However, to think of a place as big as our school, for example, one has that been operating for years and years, the long-term effects or the long-term consequences of how much energy we consume when we use traditional lights overrule how much energy we consume if we transition to LED lights. So that is our conclusion, and we hope that you find our project beneficial.
Hello everyone, so our topic is about the impact of sunscreen on aquatic habitats. It aligns with the SDG goal 14, which promotes water sustainability and reduces the water pollution underwater. We tested two different types of sunscreens. The first one is the chemical sunscreen, which contains compounds like avobenzone and oxybenzone, which can cause a decrease in the pH of the water, which can cause coral bleaching, as you can see in the model. Coral bleaching is basically when corals lose their colors, and therefore fishes don't have a home to live in anymore. Next sunscreen is the physical sunscreen, or so-called mineral sunscreen, which contains compounds like zinc oxide and titanium dioxide. Those increase turbidity, basically increase or reduce water clarity and increase water cloudiness. Water cloudiness can block sunlight from entering the ocean, therefore preventing photosynthesis, which basically disrupts the aquatic plants. Solutions for this issue is 3. First of all, apply your sunscreen 20 to 30 minutes before entering the ocean so that your skin can absorb it and less of it wears off into the ocean. Second of all, you could do awareness campaigns since summer is coming up and no one's really aware of this topic. Third thing is basically washing off before entering the ocean. So you put your sunscreen, you take a shower, and then you enter your sunscreen. Thank you so much.
Hi, my name is Zainab.
Hi, my name is Farah.
Today our project is about astronutrition. The reason we decided to do about astronutrition was because Bahrain's recent accomplishment Al-Mundar, which inspired us to do something about space and to also contribute to Bahrain's accomplishment Al-Mundar. So today the aim of our project is to understand the nutritional needs for astronauts as well as understanding the effects that affect their microgravity when they're in space. We related this to the SDG goal of zero hunger because when astronauts go to space, they precisely calculate how much food they need, how much grams of protein, calorie, everything gets into consideration before they go to space, so they don't deal with food waste. Humans on Earth on average waste 1.3 billion of food yearly. If we do the same thing that astronauts do, we can reduce this and achieve the goal of zero hunger on Earth. So my friend Khala now is going to explain the effects of microgravity in space.
So, I'll be talking about how microgravity affects metabolism and how that in turn affects muscle and protein loss. So, two factors go into consideration when this happens: anabolism and catabolism. Basically, anabolism is when your body's anti-air pathways become suppressed because you're in space. So your body has a hard time receiving signals to grow muscle mass and use your protein. Secondly, catabolism is when your body breaks down muscles because it thinks it doesn't need these muscles since you're in space and gravity affects how you use your body.
So now, after understanding the effects of microgravity in space, we need to design an effective food system for astronauts. To design an effective food system, we need to understand the nutritional needs. An astronaut needs more calorie intake, more protein, and they need to take supplementation in order to stay healthy while they're in a space mission. For their calorie intake, they need to take 1,000 more calories than an average person on Earth because when they're in space, they're constantly adapting to the microgravity environment, which requires more calories. And for protein intake, astronauts need more protein because when they're in space, they're constantly losing muscle density. And if they take more protein, it's gonna slow down the process of them losing their bone density. And for supplementation, they need to take more supplementation like vitamin D and calcium to help them stay healthy while they're on space mission. And other factors like their age, gender, height will need to be taken into consideration to design an effective food system. Thank you.
Hello everyone, welcome to our project S'mores. Now, have you ever wondered how much you're harming our environments by cooking and driving? Well, while cooking, you burn fossil fuels which emit toxic gases into the atmosphere which are harmful for our environments. And while driving, you burn gases and car oils which emit carbon dioxide and nitrogen oxide into our atmosphere which are equally as harmful. Now, have you ever thought of a way to reduce these gas emissions? Well, we have, and we're going to present it to you now. Now, before we begin, I would like to give you a brief introduction on what we will be doing and how we will be going over our presentation. Now, first of all, we will be presenting to you how we, as a group, achieved sustainable development by combining all the G4 sciences into one creatively constructed project. We will also be going over the explanations of what both our models are and the systems that they are related to, along with their applications to real life and the sciences and SDGs. Now over to my colleague Zahra to explain to you what a solar oven is.
So what really is a solar oven? A solar oven is a device that captures sunlight energy and turns it into heat energy, which is then transferred to the containers and then used to cook up the food. And My colleague will be explaining what a transportation robot is.
So a transportation robot is a machine that transports items, and it uses a rechargeable battery for energy, and with the help of kinetic energy, it continues recharging without needing any electricity.
So our project was derived from the research question, how can the collaboration between a solar oven and a transportation robot contribute and promote sustainable development? And we have related our project to multiple SDGs, and we will be naming a few of them.
Okay, so for the first SDG is no poverty, and the reason why this applies is because for the solar oven, they can use this energy from the sunlight to turn into heat energy or electricity, so it's more accessible to them and it's a lot more affordable.
And as for the second SDG, labeled Zero Hunger, our project relates to it as considering the fact that you don't need electricity or any other form of modern power, people could get cooked food easier and faster.
And for the third SDG, which is good health and well-being, our project relates to that because it allows people to use renewable sources, which in turn reduces the impact on the environment and any respiratory health problems. Next up is our real-life applications for our project. So for the solar oven, a real-life application would be cooking in rural areas. This is because in rural areas they have limited access to electricity and fossil fuels in general. So they're able to use a renewable source such as sunlight to cook the food without needing full access to such materials.
And for the transportation robots, a real-life application is in restaurants to reduce human error and increase efficiency, and also to be more hygienic.
And now we will be going over to the science applications and how our models are related to the sciences. As my colleague explained chemistry beforehand, I will be explaining the physics aspect of the solar oven and the computer science and physics aspect of the robot. Now, for physics, when we look at the solar oven, as the sunlight shines down, it is reflected by the aluminum foil and into the inside of the solar oven, which has containers of metal inside, which are very good conductors of heat, which means that if you were to place food inside of them, if it has a low specific heat capacity, this oven will be capable of heating it. Of course, this is a prototype and can only handle foods of low specific heat capacity. And as for the robot, it uses physics as we have a rechargeable battery here, which allows us to convert kinetic energy into electrical energy. And this definitely helps us reduce the emissions of gases, as we only need motors and batteries to run the robot and nothing else like gases or oils. As for computer science, the robot has been thoroughly coded and tested beforehand, and it is now in perfectly working condition.
As for the chemistry aspect of the solar oven, it requires a specific amount of heat to be able to break down the bonds in between the food particles, and that is used through the energy that is taken from the sun. And since this is just a prototype, as my colleague has mentioned, it is unable to cook bigger food meals, and it's only able to cook smaller meals.
And for biology, when bacteria reaches a certain temperature, it can get killed. So this promotes safe food. And for environmental science, both of these use renewable energy, so that promotes more clean and sustainable energy.
Hi everyone, so today we are going to be discussing our topic called carbon capture. So basically what we want to do is we take the production of cement, we take the carbon dioxide produced and we convert it back into the reactant that makes carbon dioxide. So it's like a recycling process that reuses the waste product to turn it into the reactant, which aligns with the SDG Goal 13 climate action.
So why did we choose this topic? We chose this topic because it's one of the biggest issues, with carbon emissions being one of the third largest problems with climate change. And we also chose this because it really aligns with the SDG goals.
And also because it's a very crucial issue, not only around the world, but in our own country, Bahrain. As Bahrain is also a developing country, a lot of cement production is required for producing buildings, houses, and manufacturing, etc. So that's why, by doing our micro research, we can show how this cement production can be used to help aid the manufacturing processes in our own country. So this is some images of our setup that we did in the lab of our micro experiment. And how does this relate to the sciences? So in biology, the CO2 levels that affect plant growth, climate patterns, and ocean chemistry. So basically, how does the carbon dioxide affect the environment? For both ESS, environmental science, and for biology, you can say about how the carbon dioxide emissions, they affect plant growth, they cause global warming, etc. And for the chemistry segment, we can see how the experimental setup is basically like, it shows how the reactant, which is called calcium carbonate, it breaks down to form the carbon dioxide gas, and how we take this gas to turn it back into calcium carbonate.
And for physics, we use the ideal gas law, which is PV equals nRT. And this shows us and helps us calculate the amount of, the volume of carbon dioxide that's being released into the atmosphere.
And for computer science, we created a website with an article to explain how this production happens and how the experiment works. So with computer science, you can see how we can use technology to showcase scientific knowledge. Now, what have we learned from this project as a group? Well, for the IB program, wants the students to learn more about how we need to focus on the process of our project and not just the final product. So even though there may have been a few mishaps and accidents or mistakes in the process of the project, but that doesn't matter. What matters is what we have learned together as a group and our collaboration and the skills that we've learned together.
So to conclude, we're basically just showing how we can capture carbon from the atmosphere and recycle it from the production of cement to make it back to one of the reactants to make it more environmentally friendly.
So our project is about creating a natural fabric dye from recycled coffee grounds. We did this by recycling coffee grounds, used ones from the Healthy Calorie canteen in the reception down. In the procedure, we pre-soaked all the fabric samples, which are nylon, silk, and more, and then we soaked them in the coffee grounds to extract all the natural dye. We soaked them all evenly for 1 minute. Now, when it comes to SDG goal,
so our SDG goal is sustainable communities and responsible consumption and production.
We dump them into the garden of the school. We use it as a fertilizer for the plants. So when it comes to how it links to all the sciences,
for example, chemistry is at the core of what happens during dyeing. It explains how dyes interact with fabrics and the importance of pH levels in achieving the desired color. And biology helps us understand the life behind the colors we see in coffee. Dyeing, tanning are the key players providing rich hues. But biology goes beyond just the size of the color. It also reveals how different fabrics absorb dyes uniquely. This knowledge allows artisans to choose the right microorganism that can affect dye solution. And in computer science played a role in documenting and sharing our experiment. We created behind-the-scenes digital video to showcase the process and generated a QR code to make it easily accessible and demonstrating how technology can support science, communication, and education. And with physics comes into play when we think about how heat affects dye extraction. Applying the right amount of heat helps release those beautiful colors from coffee grounds. And in environmental science brings a vital perspective on sustainability to the table. It encourages us to think about where our materials come from and their impact on the planet.
So when we finished the experiment, we created a CSV file with all the different fabrics showcasing the dye effect, and then we also did a second experiment where we changed the concentration of the coffee grounds, but we used the same amount of water. This shows how the more concentration of coffee, the more powerful the dye is going to be on the fabric.
Recently, temperatures in Bahrain are becoming hotter and hotter due to climate change. While many of us think that air conditioning could be the solution, however, they contribute heavily to this. How, you may ask? Well, they produce hydrochlorofluorocarbons, which are greenhouse gases. Moving on, let's start with the layers. Vegetation is the greenery at the top. And the root barrier prevents the roots from seeping into the building, damaging its structure.
So what's to come from Planet Estate for about 10 years? Well, we can see job opportunities rising in like urban farming or other urban sectors, and due to the process of photosynthesis where carbon dioxide is going to turn into oxygen, the air is going to be purified and it's going to cool down the surrounding temperatures. So it could help combat climate change and overall help the environment.
The ideal house, made of materials of such delicate and sustainable materials you'll never want to leave again. How did we get to this point? Sharif will explain.
So we did 3 tests, on a clay house, a wooden house, and a metal house.
So how did we get to that point? So for the metal house, we did 3 tests, the wind, heat, and water. For the metal house, it passed 2, the wind and the water. However, it failed the heat test as it is a good conductor of heat. So the temperature was too high. For the wood house, it failed all the tests except one, which is the wind. As the rest, it was too unstable. And finally, the clay house. It passed all of them except the water test, as when we put water onto the clay, it started cracking after it dried, which is a big problem. So then, we took all of those materials and we put them into the ideal house. Made of perfect acrylic glass, sustainable, and water resistant and heat resistant. Next up, solar panels. This is how you generate your electricity. 0 electricity bills have you paid to the government. So the rainwater would be put onto the roof, as you can see here, and it would fall down into the water filter. See, it goes down. And then the generator, which will be turned on, purifies the water by heating up the bacteria and killing it off. This water can be made for drinking, for showering, for anything that is used by you. Next up, on the other side, we have the rainwater as well, going down into the biodiversity of the garden. Grow your own food, grow whatever you want. Everything is perfect. The inside is made of aluminium, which traps in heat and traps in coldness, so that you feel cold during the summer and hot during the winter. No matter what you are, the temperature will stay the same all throughout the seasons, which is why I believe that this sustainable house is the perfect house.
Hello, today our group has investigating the cooling efficiency of eco-friendly materials. So before we experimented on this, we have wondered how we could help our own country. So what we have thought about is its climate and how we could help people overcome the issues they found through with it. Which we have found that people suffer from electrical bills, especially in the summer. Because Bahrain is a very hot and humid country. So what we have thought about is to use insulation. However, the issue we have found is that insulation is the synthetic insulation is very bad for our environment because creating them releases a lot of chemicals into the environment and when using them.
Okay, so our aim for this experiment is to obviously investigate the effectiveness of natural materials, which is cotton and leaves, with synthetic materials, which is bubble wrap and foam, polyfill. Our hypothesis is that obviously the synthetic materials would work better because it's built that way. However, the natural materials would come close to that. So the way we did our materials is that we took a beaker, we wrapped it, as you can see here, we wrapped it with the material. For example, we took a beaker, we wrapped it with 2 layers of leaves, we put hot water in it for the heat, we trapped it with a lid, and we checked the temperature for every 5 minutes for 20 minutes. And after this, we came to a conclusion that polyfill was the best for insulation. But obviously this is because it's synthetic and it's made in that way, and it's non-biodegradable, which harms the environment. But what came close to it is cotton, as you can see. It's very close in number, which means that we can use cotton, a natural material, as a solution or an eco-friendly material instead of using synthetic materials.
And what we have done is we used the data we have found to simulate a graph using a sort of code. What we have found is that it also follows the data we have found, which shows that polyfill is the best at insulating, keeping the indoor temperature as far away from the outdoor temperature, and cotton being the second, what we are focusing on.
The way this links to our 5 sciences is, for bio, we use natural materials, which are such as cotton and leaves, and they're obviously made out of living organisms, which make them biodegradable. So they don't really cause harm to the environment. And for chemistry, each of the materials we use have their own chemical structure, which lead to them having their own chemical properties and how they trap or release heat.
For physics, we have seen which one performs better through the related heat. Physics allows us to see the transfer of heat and what is inside of the material that allows it to be better as an insulator.
And for ESS, we used natural materials, and we were experimenting natural and synthetic materials, and we wanted to show how the natural materials do come really close to the synthetic materials, and we wanted to show why it's a better option and why it's more sustainable and how it doesn't really harm the environment.
And for computer science, we used a built-in graph such as these to display our experiments and our results of these experiments. So the way it relates to Bahrain, Bahrain is a hot and humid country, as you know. So these eco-friendly insulation materials would help reduce the electricity bills of this country, would also save money for citizens in Bahrain. Using these eco-friendly insulation materials would help benefit the economy by introducing more job opportunities for people worldwide. So with this experiment, we came to a conclusion that even though synthetic material is good for trapping insulation, it's bad for the environment because it's non-biodegradable. But what comes close to it is natural materials, and we can use these natural materials as a eco-friendly solution for these synthetic materials, which would help the environment because it's biodegradable and help the planet with saving income. Thank you.
What if I told you we can live coolly, comfortably, while also saving the planet without using AC at all?
So as we know, ACs are extremely energy draining and consuming, but we still continue to use them every day. This is where our passive forms of design help us in cooling our environments and keeping us comfortable.
Okay, so we have designed 4 tiles of buildings, each one with a different adaptation to help adapt to the inevitable humidity in Bahrain. So Noor will be talking about the first 2 models.
So as you can see here, this one has a vent. This promotes convection. Convection is where air is exchanged. As you can see, the vents is conveniently placed up. This is where the hot air comes to travel up and liquid air comes to travel down, keeping us comfortable. And this next one actually has some salt in it. So salt would absorb the humidity and the water inside of the air.
Okay. Lastly, onto the building with aluminium. So this building kind of correlates with physics, where if you incorporate aluminium into building materials, the heat will actually be reflected off the aluminium, excusing the percentage of use of AC. Now on to the last 2 models. The first one is aluminium. So in aluminium, when the light rays are passed onto the aluminium, instead of absorbing it, making the house more of a humid and hot environment, it actually reflects off the light, therefore reducing the strength of the humidity. And lastly is a control variable with no adaptations and no significance. So what conclusion did we come with? So we've measured the efficiency of each adaptation according to the amount of condensation. According to our results in the lab, the sea salt model had the least condensation, and obviously the control model had the most condensation.
So as for the scientific integration, we have biology, chemistry, ASS, and physics. So for chemistry, we're going to be talking about the properties of condensation, which is for water, as well as hygroscopic properties for salt. So salt will absorb the water in the air, which is what hygroscopic is. For physics, we have radiation and convection, as explained for the vent. Air will be exchanged and it will prevent convection, as well as the aluminium, which Julia has explained. It will be reflecting off the light, keeping the internal environment cool.
Now, what about biology and ESS? So ESS, in short, we can say that just emitting these strategies into building materials can help reduce our carbon footprint while also reducing energy consumption. Biologically, we can relate this to a process known as homeostasis, which is basically the stability of our internal body temperature. And with homeostasis comes vasodilation, which in short is when our blood vessels expand in order to be able to release heat. Thank you very much.
Our project is about eco-friendly water filtration methods, which aims to bring clean water sources to water-scarce countries and areas.
In our method, the materials we used are sand, gravel, and cotton, which are materials very easy to find and are very sustainable and come at low cost, making them available for people in low-income countries and water-scarce areas. Because of our experiment that we performed, we found this method very effective because it removed the sediments from the water and regulated the pH level of the water.
This experiment helped with SDG number 6, which is clean water and sanitation, and it helps bring clean water sources for low-income countries that are unable to get their hands on clean water sources.
Yes, thank you.
So my project is about waste management, following the SDG Goal 12, which is responsible consumption and production. So we created a survey before conducting our experiment to calculate which waste is more produced in school. So we found out that the common areas that is in the playgrounds and in the school canteen. And the most type of waste the most of type of waste that is generated is plastic and paper and food items. To help balancing with recycling in school, we created 2 cardboard boxes to dispose of paper and plastic, and we put covers on them to see we covered them with wrapping that has something that grabs the attention of students. For example, for the girls, we put coffee and matcha, and for guys, we put 2 football players that are very popular. And we got a decent amount of waste, and like compared to the school's recycling bins. And before conducting our experiment, we checked the recycling bins present in school, and we asked the cleaners, do they use these bins? They all answered that no, they either throw them on the ground or they throw it in the garbage. So this method was considerably better than the other trash can, the recycling bins, because it brought the students' attention and they made them engage with the recycling and found it entertaining.